One of the things that I really love is the function as a service approach on top of Istio, on top of Knative, on top of Kubernetes, because you then get full observability of the whole platform. You can apply this intrusion detection. You can use your namespace aware tools in order to introspect more deeply. And you can also satisfy what ultimately the kingmakers, the developers, require, because there's no point building a secure system if the developers can't ship business functionality through it. So, platform for functions with Kubernetes is underneath.
Hello and welcome to Committing to Cloud Native, the podcast where we talk about the confluence of cloud native technology and open source. Super excited to talk to you today. Been a while since we've had a podcast. Very happy to be back at the track or whatever. I don't know, something. Anyway, our other panelists we had today, besides the illustrious Richard Littauer, that's this guy, is Justin Dorfman. Justin, how you doing?
Doing good. How are you, Richard? It's good to see you again. It's been a while.
Always good to see you too. Although the hat still has something on it. It's a smudge. Kind of looks like LA. Should say New York City. I don't know what's going on there. Anyway, we have a guest on this podcast, which is good for all of us listeners because it would be the worst if Justin and I just talked. I'm talking about Andrew Martin. Andrew?
I'll be whoever you need me to be.
Yeah. We have Andrew Martin on today, who has just said he'll be whatever he needs me to be. Andrew, I need you to be the CEO of Control Plane. Can you tell me what Control Plane is and does?
Control Plane is a cloud-native security consultancy, training, and pen test firm. So if it looks like cloud-native and it smells like security, we are interested.
Awesome. I understand what that is pretty intuitively. How many people do you have there?
We're up to about 30 people and still expanding, taking on security architects and threat modelers and all that good stuff.
I'm familiar with the security field. I kind of know what pen testing means. I know that there are people out there who are literally hired to take axes and wire clippers and go through fences and figure out how to get to servers, which is the coolest job ever. For my benefit, because I don't know, what's the average size of company in this space? Is it like 5 people? Is it like a solo Polish dude and working out of his apartment? Or is it does Black Duck have 1,000 people? What's going on there?
There's a huge variance, and actually we should be just as concerned about the solo dude in his basement who may have an incisive way into our systems as some of the bigger organizations. Of course, in the UK for penetration testing, you have organizations like NCC who do a huge proportion of the market. But then you also have the smaller boutique firms that focus very specifically on the cloud native aspects and the interactions between the cluster and the cloud, the IAM integrations, how things are configured in CI/CD, getting into the supply chain and all that good stuff. Yeah, we like to think we operate on more of a intuitive than check mark based basis.
Cool. So that makes a bit more sense. Now, dumb question. Security for cloud native. I thought cloud native depends upon actually using other people's code. So when I'm using AWS, I'm depending on AWS's security. Why do I need extra security on top of that?
The shared responsibility model gives us a different level of interaction with our cloud provider based upon what is ultimately platform as a service or infrastructure as a service, or software as a service as well, where Gmail, you don't see the servers, but for the infrastructure from, for example, GCP, well, you're actually interacting with the servers and you have a responsibility to secure part of that stack. So we trust the cloud provider to encrypt our data in transit, to make sure that there's suitably advanced encryption and folds and envelope encryption so that keys can't be retrieved and so that our data at rest is safe. But when it comes to how we behave operationally, the cloud provider can make no guarantees that we're not shipping bad code to production. First line of defense for any cloud-based application is the socket that faces the internet. That's behind the load balancer or whatever that would be. And as we go to just serve our application code, well, that's developed by us and our developers. If we have a structs like remote code execution in that web-facing tier, well, then all of a sudden our adversary can get in to our infrastructure. And as I say, that's not something that the cloud provider is able to give us any guarantees over because they have no insight into what we're deploying. That's very much the delineation of the model, how it's supposed to work. So what do? Well, we can use the raft of modern cloud native, specifically kind of containery namespace aware tooling to run lots of processes on one host, let's say like our Kubernetes style, lots of containers. And for each of those containers, we can attach a granular security profile. So if we think back to the LAMP stack, we would have a VM with, obviously it's running Linux. We have an Apache web server, which needs capabilities and permissions to bind to a port below 1024. That's a privileged operation. Then we've also got MySQL, which wants to bind to a port above 1024. It's a 3306 if memory serves. So applying the same policy to the whole VM, it isn't practical. You have to do that on a per process basis, and that just gets laborious. And traditionally, we've got stuff like Dan Walsh, don't turn off SE Linux. It's a kind of lifetime crusade. SE Linux has this level of granularity, but it's difficult to configure. So cloud native gives us containers. Containers gives us a single process per container model, and that container is an easy and relatively well-hardened security boundary. And we can configure that per process. So we have very high fidelity of policy, very granular application on a per process level. And when we get that remote code execution into our container, because we've got that vulnerable application library, we can go in and say the baseline behavior for this process has deviated. We've spawned a shell. We're making other strange network requests that we wouldn't do normally. And that's the delineation between the cloud security that we get from the vendor, which is those underlay encryptions and data at rest, and the lifeblood, the data when it's actually passing through the system and narrowing down the attack surface and then running cover with type policy for each process that we run.
Are you sure not CEO/Chief Marketing Officer? Because that's just very clear. So thank you so much. You mentioned Kubernetes at one point, and I do want to get to your book that you wrote, Hacking Kubernetes, which is going to be very exciting. Before I get there, now that we have enough background to know that you know what you're talking about, how did you get involved with Kubernetes? How did you get involved with cloud security? What's your background?
I was very privileged to come straight out of university and into a startup where I did the traditional hat juggling that startups are well known for. And that gave me the opportunity to migrate bare metal servers onto Amazon AWS in kind of 2008, to deal with PCI audits, to do database query tuning, to expand into multiple different types of programming language. And that gave me the kind of generalizing specialist angle on things. And that really plays to my inquisitiveness, which is probably a superpower and a huge distraction, and meant that I had the ability to kind of learn about various different domains. I moved to London about 10 years ago and was just kind of looking for difficult problems. You can build high traffic websites and fine tune them and deal with your requests per second at all the different layers of the stack. But actually, when things get really difficult, that's when regulation turns up that specifically, for example, it puts an extra hop in between things. And you're looking at trying to do a low latency service, but actually you have to deal with some sort of reverse proxy, some sort of step up gateway kind of thing. And the nature of those problems really appealed to me as an engineer because, of course, all engineering is a compromise. It's about finding the right thing to fit into the whole. And when that set of compromises is regulated, then it becomes a slightly more difficult and interesting set of problems. So subsequently, I ended up moving through various financial institutions, ended up at the UK Home Office, and they were ahead of their time. So thanks to what was called the GDS, Government Digital Services. Oh, and incidentally, the Home Office in the UK is a governmental department. It's the Ministry of the Interior rather than sort of the ubiquitous back room, which we all share these days. So the Home Office were advanced by virtue of these previous projects, and they were running Kubernetes 1.2. So I turned up dealing with critical national infrastructure deployments onto air-gapped Kubernetes. And at that point, it was clear there was obviously 1.2 with kind of pre-RBAC, with pre-network policy, pre-dynamic admission control. There's a huge number of things that were widely known security footguns in Kubernetes. But because I've been deploying containerized systems for a couple of years preceding that, it was clear to me that this was the direction of travel. And the pod concept enabled any application deployment topology. That really differentiated from Docker Swarm, which looked like it had a horse in the race for a while. And so I doubled down individually and sort of commercially. So seeing that we had this fully declarative interface to Kubernetes where YAML as far as the eye can see, I built a static analysis tool called kubesec at kubesec.io, which uses a beyond core risk model style for Kubernetes resources. this pattern of static analysis on resources, on plans, kind of Terraform style infrastructure as code, as well as the deployment as code, sort of brings us to a place where we have stuff like OPA today, the generalized open policy agent. And yeah, saw a talk on that about the same time. It was very clear the direction of travel of cloud native security. And it takes the journey to almost 4 years next week.
Wow.
For those of us listening in the past or the future. So yeah, perseverance is key.
You brought up Docker Swarm. Why do you think Kubernetes succeeded and Swarm didn't?
That's a great question. Potentially the answer is to do with the lack of pod support. So with a single process per container, Swarm was only designed to run single containers, which meant that we had to run more processes in one container. So we don't have the useful init sidecars. We don't have sidecars for logging or security or service mesh Envoy style. And service meshes were being shipped by Docker Swarm before they were cool. They created a mutual TLS overlay network across the base network between the Docker Swarm nodes, over which the micro-segmented application networks were able to communicate. That's a pretty advanced networking model compared to the more flexible but less well-defined CNI model in Kubernetes. Of course, we only got network policy in Kubernetes because Calico shipped it. And as with other things, the interface was extracted from the Calico implementation and baked into Kubernetes core itself. So from a networking perspective, Docker Swarm was much better out of the box because it was batteries included, but changeable, and came with its own networking paradigm. However, the inability to run multiple containers in a pod meant that there was no flexibility of application topology, and that's really where Kubernetes stole the show.
Thank you. That's a really great answer. You're an expert with Kubernetes. In 2019, you made some predictions, and I want to see what came true and what didn't. Hosted services catch up with GKE. Did that happen or not?
To some extent, I think GKE, and full disclosure, we wrote the CIS benchmarks for GKE in this year and contributed back some sort of thoughts and ideas around the supporting services. GKE still continues to push the envelope in terms of how Kubernetes is run and how it integrates with the cloud. A good example would be we have the kind of Fargate EKS hybrid in Amazon AWS. Google's kind of GKE response to that is GKE Autopilot, which removes the node abstraction. It's advanced thinking, and it's definitely pushing the paradigm. So I think GKE continues to sort of lead slightly other things like binary authorization, supply chain security before it was cool, again, in inverted commas. So yeah, I have a soft spot in my heart for GKE, of course. And yeah, I still think it edges ahead somewhat.
Shout out to Dan Lawrence there. Second one, non-container VM-based isolation improvement. Did it happen?
Oh, yes, this blew up. So we've now got things like gvisor, which is ultimately for App Engine to run. Google had this huge infrastructure, all these Borg cells, flexible compute to host Gmail and Google Search and Calendar and Maps. And that was how Google deployed itself globally in these self-contained cells. So Amazon turns up and starts renting compute in the form of AWS. And Google say, we can do this. Why aren't we doing this? And the first thing that they build is App Engine is running untrusted third-party code. That is my code and your code on Google's Borg infrastructure on the backplane. So in order to isolate those workloads from the underlying Linux kernels, Google built first version of gvisor. And gvisor is a user space kernel reimplementation, which means it catches system calls before they hit the kernel and handles as much as that as possible in a Golang-based kernel emulation. This moves the untrusted code further away from the Linux kernel interface, which of course is written in C, and so still definitely harboring loads of 0 days that are probably being exploited somewhere by somebody. And it gave the Google security team that warm, fuzzy feeling of security. They do a couple of other things with gvisor, including dedicated I/O, dedicated TCP/IP stack. You can run it in various different configurations, but they realized they were onto something here. And gvisor is now also runnable as a container runtime for Docker. It will run in GKE. If it's installed on a host node, you can start containers that are wrapped with gvisor. And it means that, again, if an untrusted process is running, and by that I mean stuff perhaps, or video transcoding, because they're very complex, is often somewhere that you can see bugs. Image tragic was a good example of how difficult it is to do that safely all the time. Maybe it's also a particularly risky workload, as in perhaps we allow untrusted code to be executed within. And so if somebody gets remote code execution or we gift it to them or whatever it is, they can't run exploits against the kernel because they've got this shim, this gvisor layer in between. So it's a kind of VM-based isolation. We've also got things like Firecracker, which is the AWS runtime for Lambda, which is the same kind of idea. It's a very stripped down virtual machine manager. Inside the virtual machine, it also creates container namespaces, and it hangs seccomp off not only the VMM process, but also the process inside the VM. So these are really crazy hybrid approaches that take the best of both. They strip down the QMU and KVM virtual machine drivers and give us this kind of hybrid existence where we can still take advantage of some of the container guarantees of horizontal scalability and the resistance to churn, and add these virtual machine guarantees, which include a more difficult runtime to escape. So yes, it developed and improves, I think, is suitably inspecific to claim victory.
Andrew, you have a lot of knowledge, right? I feel like a lot of this podcast so far is listening to you. Well, you're very articulate and may just be the English accent. I don't know. But what's like interesting to me is that you're basically saying all this extra stuff and you're giving all this context for where this team moved here and this team moved there. And I'm thinking about the average listener and wondering what they may be wondering. And I think the main thing is, where do you find this stuff out? Like, what do you use to keep updated on how open source works in cloud native? And how do you know that, say, Google realized they were onto a good thing with gvisor, and so they did X? Well, how do you know that? Is there like a Medium blog I should subscribe to? What's going on?
That's a great question.
It is a great question. There are multiple layers. One is that I've been very fortunate to attend many conferences and meet some of my heroes. I mean, I met Eric Brewer at one of the KubeCons, obviously the guy who invented CAP theorem, but even so many really remarkable minds have contributed into open source in these code bases. And just going to conferences and having enough of a grounding or an understanding of people's work to ask them incisive questions is a great way to just kind of dig in a bit deeper and get some context. We're very fortunate in that we've been able to provide services, some of the cloud providers and some of the big industry entities that also sort of provide some access to this. But really, good and assiduous use of Twitter lists is really key. So instead of just following my timeline, I have a tech list, I have a sec list, and between those, I also trigger some RSS notifications, sifting through those things, kind of top Hacker News comments, not all the Hacker News comments, just helps. There's definitely some diamonds in the rough.
So staying keyed into the ecosystem is a good way. Twitter really does continue to be a fantastic way if you can avoid timeline fatigue. So using lists is a good idea. Using conferences is a good idea. Which conferences are, you say, the best ones to go to? Or do you have any that you're looking forward to this year?
Well, if all the stars align, I'll speak at KubeCon in person.
Cool.
And just prior to that is the Cloud Native Security Day. The final masterstroke, the community understanding is, of course, getting involved. And places like Tag Security, as it is now under the CNCF, SIG Security, the OpenSSF, these are all open source organizations that help to push the envelope by virtue of people just contributing their time and kind collaboration. Those are the most fascinating and interesting things. So even just combing through meeting notes to catch up on a month being away is a useful way to, maybe there's a GitHub issue, maybe you can chase a pull request down and kind of dig through some of those things. In terms of conferences though, yeah, absolutely. KubeCon, the Tag Security Day prior to that, we'll run the CTF there as well. Sign up for Tag Security. You also have the opportunity to run some nefarious, I don't know how much I can reveal, but red pill, blue pill
cool
style CTF.
Do you ever attend the Tag Security weekly meetups?
Yes, I do.
I learned a lot. My boss was like, check this out. I'm like rolling my eyes like, oh God. But then I went to him. I'm like, wow, it's a lot of great information I haven't run into you yet. Or maybe we did. I just didn't see you because there's so many people on it. So yeah, shout out to Tag Security for sure.
Yes, I managed to be a member from early doors, and then my attendance is not what it could be.
I wasn't trying to throw you under the bus or anything. Please don't think that. I think Richard brings up a great point. Like, you're expert in Kubernetes. And I think that's why O'Reilly probably went to you and said, hey, bro, you need to write a book. So let's talk about this Hacking Kubernetes book. It's not out yet. You wrote it with a fellow named Michael. When does it come out? Let's talk about this book.
I discovered by virtue of searching for it on Amazon the other day that it's due out on the 30th of November. Yes, November, I think. That was briefly concerning. And yeah, I wrote it with my excellent and studious co-author, Mr. Michael Hassenblass, who is a prolific writer already and took me under his wing to guide me through the process. It was tremendously enjoyable to write. The opportunity for consistent research and making sure that I understood a concept sufficiently to write a few sentences on it is a really positive, reinforcing learning cycle for me. And really, as I said, this acquisition of knowledge and interesting things very much powers my kind of intellectual engine. So I really enjoyed that part of the process. On the flip side, it required excessive dedication to the cause, some sacrifices of various things, such as enjoying a drink from time to time. I was just able to hand in the final draft a few weeks ago, and the cognitive unbundling that occurs when that happens, because everything that turns up is potentially something for the book. And how do I contextualize this? Cross-reference? Did I make that CVE in there? So yeah, it was a tremendously enjoyable exercise to undertake. And what we've attempted to do is analyze the threat landscape against Kubernetes, bathed in the light of historical vulnerabilities, and then try and paint some kind of future ideal hardened security state based on the impact of remediating risks rather than kind of Iron Maiden, lock everything down and can't move. Mm-hmm. So hopefully people find it in some way useful.
What do you think the most successful chapter is that you're looking forward to having people read?
I really enjoy the first chapter because it starts off with the pod and it decomposes the pod, looks at a container. And the great thing about Kubernetes container and Linux security is they are macrocosms and microcosms of each other. And the more that you zoom in on Kubernetes security, well, it's actually container security for the process, of course, rather than the orchestrator. And then you drill down there and container controls are just Linux kernel controls. And then we go all the way down and then we're back into some archaeological spelunking through why specific design decisions have persisted for however long. The book features my archetypal 8-bit nemesis, the nefarious Captain Hashjack.
No.
His prime directive is to plunder the data that courses through the veins of the example organization, of which the reader is a fictional CISO. And we contextualize a number of attacks with the intent of a threat actor of Captain Hashjack's description. So he's state-sponsored, he's organized crime level, he's where a lot of organizations today will find they potentially have problems. And hopefully this, despite being slightly fantastical, anchors it somewhere close to reality and makes it more of a useful set of recommendations rather than something a bit more abstract. So starting with the pod is my favorite piece. We actually had to move Captain Hashjack's attack on a container from the first chapter into an appendix because it took him 10 or 12 pages to truly explore the periphery. So a combination of chapter 1 and the appendix helps to set the scene for the rest of the book and ecosystem.
And do you have any colleagues of yours review the book, or is it all done with O'Reilly?
I was so grateful for some incredibly detailed reviews. So editor O'Reilly, Angela Ruffino, was awesome. She connected us with some really established and advanced authors who were very competent with their reviews and obviously preeminent in the space. Mm-hmm. I then reached out personally to a couple of people in the scene who really, again, they all get called out at the beginning, but provided some invaluable feedback and also some philosophical views on some points that were made with a kind of higher level generalist perspective, which was, it was challenging to read and it meant that I had to sort of exercise my own thought patterns on the thing. That was one of my favorite parts of the whole process. And then finally, I obviously disseminated the work, in inverted commas, to the control plane team internally. And a number of people came back, found what I would describe as critical bugs in parts of the book, and kind of we ran an internal bug bounty, and
Nice.
numerous people scored. Yeah,
Love it.
so just fabulous.
This reminds me of one of the questions I was asking myself earlier while you were talking, which is Control Plane has 30 people in it. It's a security firm. Obviously, you can't have all your tools be open source because that doesn't work for security at all. One of the questions I have is, how do you disseminate open source knowledge about cloud native infrastructure, cloud native programs through Control Plane? You just mentioned internal bounties, which is a really great idea for things like a book, but then a book is also a closed product that doesn't have to be, re-updated every time. So what do you do to make sure that people at Control Plane are actually getting the best of the open source world, without which it wouldn't exist?
Democratization and open sourcing of security tooling and information has been a constant source of utter amazement to me ever since, sort of starry-eyed, I found OWASP when I was about 20 or so. And as I said, I had this very privileged position of being in this company and having responsibility. And so I would drive to London, Bristol, which is 100 and something miles, to attend OWASP events. And at one point I received a big, thick book, and the last sort of 100 pages were all XSS attacks. And people had just printed out all the Unicode strings that would cause problems, and it just blew my mind. At some points in Control Plane's existence, I have wondered, and I know it's the case for other security researchers in the cloud native space as well, if actually we're a bit further ahead with the art of the possible than the current state of the art. And so there is potentially this is exposing things that are not yet target for attackers, but clearly they will be in some period of time. So we try very hard to open source everything. We open source the threat models that we built for the financial services user group for Kubernetes. Of course, the CIS benchmarks are open source. We've just built a new training course for O'Reilly called Threat Modeling Kubernetes, which has all of our ways and means to threat model things. So including kind of default lists of threats. Obviously, we have absorbed work that the community has done and folded that in with our own particular slant. So we claim no credit for it. We're just happy to sort of push back. Where the difficulty comes, I think, is the open core versus hosted security tool balance. And we see this with a number of tools whereby the core enforcer or scanner or security tooling is open source. And you can take that and you can deploy it in your infrastructure and you can have a good result. But if you want to do that at scale and have an awareness of what these things are doing over multiple, perhaps clusters or nodes or availability zones, that's where the secret source kind of SaaS hosted piece comes in. The only thing we don't open source is the infrastructure behind our Kubernetes simulator project, which is what we use to run the capture the flag events at KubeCon. This is because it's big and spidery. That. Yeah. We've been running that with tag security for the last 2 or 3 events. And we have a wonderful time. The community coming to contribute, and it's awfully good fun.
Yeah, no, I hear that's like one of the biggest side events there. And it's so cool that talking to the creator, that's pretty cool.
You don't mind, I want to see if we can get behind the creator's brain a bit more to help out future participants of Capture the Flag. Earlier on in this podcast, you were talking about how you ended up at Control Plane, and you said, I was looking for a difficult problem. And you've also mentioned several times that you're incredibly privileged, which this is, to me, those go together. Once you've solved the bread and butter, once you have rents covered, a lot of people in our circumstances, I include myself in this, are looking for difficult problems. And I think for you, it's a particularly interesting question because you're a security researcher. And security researchers, by default, are looking to find ways around things. They're looking to find problems, questions, answers, which are not public, which are hidden, which are not going to be written somewhere in an easy 1, 2, 3-step guide. So I'm curious, and I'm not sure how to best phrase this question. I've been thinking about it, whether to ask, what's interesting to you, or what method do you use to find an interesting problem? And how do you do security research in a way that makes you feel really excited about doing that sort of work? What does a difficult problem mean to you? How do you approach that question?
Yeah, that certainly triggers some self-reflective thoughts. I think the most important thing, speaking personally, but also infusing teams and displaying leadership, is to infuse or inculcate a shared sense of passion for a thing. And I'm very fortunate, again, in that everything in Cloud Native is shiny. And so it's easy to find things that are, and we have this concept of flow from a psychological perspective. If something is a little bit more difficult and we're a little bit less comfortable with it than the average, we can get into this state of psychological flow where we're kind of chasing the dragon of intellectual stimulation. And being in that quadrant of the graph is where I try and organize my time as an individual, where I try and infuse the organization that I'm very lucky to be a part of, and finding those things that inspire passion in people and then performing research on them. It's kind of a happily conducive feedback loop into itself. So finding that level of challenge rears its head up with the interest levels of technology. So right now, there's a lot of interest in next generation process isolation and those kind of gvisor and kata containers and all that firecrackery good stuff. There's also a lot of interest in eBPF-based kernel instrumentation and process analysis. That's, again, there's been so much momentum building up for this, and the tooling is all available, and we've just been waiting for the kernel versions in our deployed servers to catch up with the kind of 5 mainline, which brings in all this new functionality. Additionally, this gives us a whole new way to rewrite a number of tools that have had traditional problems. I mean, of course, when Kubernetes started, IP tables rule sets that were kind of in the hundreds or thousands, when they reloaded, that was a 2 to 3 second downtime on all net filter traffic, and you just have an outage. And they had to rewrite IP tables with eBPF, which is the NF tables kind of shim. So we can still interact with IP tables, but the net filter code in the kernel that deals with that is now this hyperfast, performant eBPF. So these kind of things where we know the problem space, but there's something revolutionary, can really lead to lots of new code. We want new code because it brings us new features, but of course, new code is less tested and more potentially subject to bugs. And then we're into the constant software is never finished. It's part of an ecosystem that's always moving. Moxie Molinspike can be credited gracefully for that. And these are the things that really pique my interest and kind of keep me entertained from a professional perspective.
Love that answer. Also, Moxie Molinspike is the coolest, just straight out saying that. Excellent. You've presciently answered one of the questions I was going to ask next, which is what are you most excited about in the cloud native security space coming up? And so you've already covered a few things. This may be a good point to go back to your 2019 Kubernetes predictions. The last one, or the one we were going to get to, was that the Tangle of YAML was going to unravel by 2019. Did that happen?
But to some extent, there were, leaps, bounds, and steps at least taken in the right direction. We see things like Kustomize that make things at least easier to template across different environments. But I think the underlying issue of kind of meta templating or like higher order templating over YAML is still almost where we are.
Cool. Okay, so it hasn't happened yet, but may in the future, we hope. What about image and build metadata security matures? Has it matured?
Yeah, that's a great one. He says self-referentially. Well, looking back on it, I appreciate the fact that I wrote it, let's say. What we've seen is tools like Cosign move into this space and so Control Plane have been hugely supportive of work out of the NYU cybersecurity labs like TUF and Intoto over the past few years, but they were always lacking adoption. We saw Notary that was able to bring content trust, as they called it, into Docker, but required a secondary server to be deployed alongside an OCI registry. And that overhead it was too much for most organizations. It's not a great deal of difficulty, but there was no stimulus. Suddenly we see the SolarWinds class of attacks, but we see the kind of Revil pipeline attacks as well this year. And broadly, supply chain just enters the public consciousness at 1,000 miles an hour and starbursts when it's there. And suddenly everyone's talking about supply chain. What we've now seen is this use of image and build metadata in all sorts of different ways. So there's this amazing project called Recore that will take the hashes of things that we've built and put them in a append-only transparency log. And we can now do this for binary artifacts. And then you've got tools like Cosign, which can integrate the update framework with container signing and give us this brand new signing style that actually encompasses all of the existing state of the art with one sly innovation, which is to put the signed metadata and signature into an OCI image and push it to the same registry as the image that it's signing. Because we're using that unique identifier for the image means that we have an immutable or a hash-based link between the two. And we can then deploy to production, validate that some evidence lake or Recore or some external system has proof that thing was signed, revalidate the signature to ensure that it's signed by somebody that we trust. And then finally, that's our admission control into Kubernetes in production. The state of the art is now integrating Tecton chains, whereby in toto is baked into every build step. You get to the end of the build, you build a container, you sign it with Sigstore. That implicitly trusts all of the cumulative in toto stages before that. And we're into an amazing place where we can add software builds of materials into here and sign those too. While we may not have fixed the ultimate problem, which is third-party code risk is very difficult to hedge against, and GitHub is full of potentially untrusted code, we're now in a position where we are much stronger against insider threats. And in the event of a discovery of potentially malicious code, we know which containers or which systems have that code deployed, and we can operate an effective patching strategy.
Are you working with Dan Lorenz on that because of Sigstore?
Yes, we have worked with Dan Lorenz and Luke Hines in the Sigstore project.
Shout out to Dan and episode 20. You can hear more about that.
Cool. So you had one more prediction in 2019, but I think in the interest of time, I want to ask a different question, which is, do you have any predictions for 2023?
Nice.
Okay, that's a great question. Kelsey Hightower has been saying that Kubernetes is for building platforms. It's not the platform itself, building platforms. I think we're moving closer and closer towards that. What's happened over the past 5 years is that big companies who've built platforms on top of Kubernetes have been subsumed into larger organizations. We still haven't quite seen the thing. Rancher is doing an amazing job, but again, sort of bought by SUSE last year. So still some sort of abstraction over Kubernetes, I think kind of makes that a little bit easier. I really love the GCP Cloud Run functionality, which takes a container and just runs it by itself. We're back into the same swarm question there because, of course, it's a single container. You don't have the Lambda secondary or security container thing that get there. But GCP Cloud Run runs on App Engine, so through gvisor onto App Engine. But it's Knative compatible. So actually, one of the things that I really love is the function as a service approach on top of Istio, on top of Knative, on top of Kubernetes, because you then get full observability of the whole platform. You can apply this intrusion detection. You can use your namespace aware tools in order to introspect more deeply. And you can also satisfy what ultimately the kingmakers, the developers require, because there's no point building a secure system if the developers can't ship business functionality through it. So platform for functions with Kubernetes is underneath.
When we had Kelsey on a couple months ago, that's what he was saying. He says Lambda and in OpenFaaS functions as a service. That's the future of like software development. And I don't know if it would be 2023, but who knows? I mean, maybe it will be. It could totally shift.
We certainly see that with some of our customers now. There is a hybrid deployment approach when they're trying to build global platforms in multinational organizations, where they're interested in targeting everything from a virtual machine through a Kubernetes into a serverless platform. And of course, developers will go for the least friction. Operations teams probably want to have some balance of uptime and availability and observability for things which traditionally have been slightly more difficult with function as a service. We've had to do things like keep functions warm by pinging them every so often, just because the underlying runtime will garbage collect them. So there are still operational and developer frictions when it comes to running these things in production.
Interesting.
Certainly, I do see it as the direction of travel.
Awesome. Great answer. Thank you so much for coming up with that on the fly. In fact, thank you for talking just in general during this entire podcast. It's been great to have you and to learn about your background, to learn about what Control Plane does, to learn about your new book coming out November 30th for all of you who are listening. This is going to be called Hacking Kubernetes. You have to say it with a British accent from now on. You can't say Kubernetes. It's over. So that'll be very fun. Please check that out. That's coming out of O'Reilly. It'll be available on Amazon. And we hope that your predictions 2023 come true along with Kelsey Hightower's. Now, Andrew Martin, before you leave, we know that we can access you on Twitter, and we can put the Twitter handle Sublimino, Sublimino, on our favorite Twitter list for tech, security, and probably other things if we wanted. We know we can see Control Plane at control-plane.io. is there anywhere else on the internet where we can follow along with your thinking, your words, and the work that you do?
There are a couple of interesting escapades you may wish to follow along with. One is SANS Sec 584, which I was very lucky to have the opportunity to write with some excellent co-authors and co-trainers. That is attacking cloud native and Kubernetes. It's a 3-day deep dive into red teaming and then the blue team response. So it ends up being a purple mix of the two. There is also a course for O'Reilly called Threat Modeling Kubernetes, which is the paper-based view of the hands-on SANS lab. So it teaches you things like connectivity matrices, how to model systems, and that default set of attacks and threat objects that we look to remediate against. And it should be a jumpstart into cloud-native defense.
Is that based off their Katacoda platform?
It's not actually intertwined with Katacoda yet. We do have one Katacoda exercise in there.
Cool.
But we actually go to Katacoda. It will all be embedded in the future, though. So yeah, at the end, we spin up a lab. Shout out to Ben Hall, the Katacoda head honcho.
Mm-hmm.
Well, follow along with those. Oh, audience, thank you so much for listening. Andrew, thank you so much for talking. It was great to have you on.
I've learned so much. Like, I don't think I can hold it all in my brain, but that's the beauty of this podcast is I can listen over and over. So thanks so much for coming on. I really appreciate it.
Absolutely. It's been my pleasure. And thank you very much.